So these videos, though, in this section are going to be going over multivariate regression, both when we have a single response variable, which is usually just called multivariable regression, and multivariate regression, where we have multiple response variables. And the example we're going to be looking at is the same bone data that we had for the homework in chapters 8 and 9, but now we have 8 different bone measurements, 4 different bones, both on the left side and on the right side. And we're going to be using the bones on the right side to predict the bones on the left side of the body. So we have the humerus, the radius, the femur, and the tibia. And again, the right tibia will be used to predict the left tibia, the left femur, the left humerus, and the left radius. So what are the different types of regression then? So the different types of linear regression we have is we just have simple linear, which is probably something you've seen so far before. We have a single response variable y with a single explanatory variable x. And simple linear regression just has 2 parameters. We have our intercept and we have our slope. This is your basic line that you've seen on a Cartesian plane before. And then in statistics though, our line doesn't exactly equal our response variable. So instead, we have this error term, epsilon. That's going to kind of be the difference between what our model says we should see and what we actually see. So this is kind of something innate about the person that makes them a little bit different. Even if you have the values of x and y for everyone, and even if your model is really, really good, everyone's going to be a little bit different. So we have this error term here. And then kind of the next step in regression is multivariable regression. We still just have our one response variable, but now we're going to add multiple explanatory variables. Instead of just having one x, we're going to have q different x's. So we're going to end up with still just a single y-intercept, but now we're going to end up with q different slopes, one for each explanatory variable. And multivariable regression gets a lot more complicated than just a simple linear regression does. But the model, or our equation that we draw for it, is really, really similar. It's just, instead of having one slope, we're adding these q different slopes on top to it. We still have our same type of error term, and we still have one intercept, and we still have y. And then last, a little bit more complicated than even multivariable is multivariate regression, where we have p different response variables and q different explanatory variables. So since we have multiple response and multiple explanatory, we kind of have to write it in a matrix form. So y is going to be kind of the data matrix that we've been seeing, where each row corresponds to a person and each column corresponds to a variable. This x matrix is going to be the same thing. Each row are the q different explanatory variables that we get from the person, and each column are going to be the different variables that we've collected from them. And we'll see in a little bit, there's a little bit of an exception there. And beta, this b, which is Greek beta, is going to end up being a matrix that has a bunch of different slopes in it. So it's going to have our intercepts and our slopes all built in as well.